Oh my gosh, Professor Dom, I have a math test in 9 minutes and I need your help.
Who are you?
I'm Nick.
What's your test on?
The 2011 Calc BC FRQ, number 3.
You already know what you're being tested on?
Yeah? Yeah.
Oh, that's right. You go to another school. Your calc class is a joke.
No, it's not. It's pretty hard.
Tell that to your AP scores.
It's time for calculus.
Dom is the coolest. He will teach you math. Dom is the coolest. He will teach you math. Professor Dom. This is actually a pretty cool problem. I was pretty excited when I saw that I was assigned this one because I remember liking it when I was doing it. They're able to ask a lot of different things with it, and it's pretty cool what they do. So let's read it. They give us an f of x, which is e to the 2x right here, and then they bound that within the first quadrant and the line x equals k, and they say that area right there is region R. A cool thing about this problem is that it isn't just going from 0 to some number. It's dealing with a value k, which is largely theoretical, which is cool. The first part of this question is asking us to write an expression involving an integral that gives the perimeter of R in terms of k. And I think a lot of us, when we see that, we automatically jump to arc length and we're like, okay, let's find the perimeter of this guy. But I think an easy thing to forget is it's asking us to find the perimeter of this whole shape here. So we need to be very clear about remembering to add this part, and this part. And right here they do that. 1 plus k plus e to the 2k, which they give us right here. And then now we can get to our arc length part, which we were excited about. We need to remember the regular arc length equation that's not polar or parametric or some weird one is the integral from a to b of the square root 1 plus f prime of x squared dx. So that's just something we have to have memorized, and really the only place we can be tripped up on this problem is forgetting that it's the whole perimeter or forgetting that equation right there. So let's plug into that. Our a is 0 and our b is k, and f prime of x is pretty easy to find. We're given the equation up here. It's e to the 2x, so f prime of x is clearly 2 e to the 2x. So they give out 1 point for finding f prime of x, which is a really gimme point. Like, it's just bring the 2 down. And then we need to remember that it gives us a point for having the right integral, so remembering that equation, and then a point for the answer, which is basically the right integral combined with the whole correct rest of it. Okay, let's look at part B. Now they're saying they're rotating this region around the x-axis, and they want us to find the volume of that in terms of k. So this one we do have to do a little solving down for. It's not as easy as our setup but do not evaluate. We all remember this from AB. It's just a matter of remembering it correctly, really. So it's really important to remember here that our volume in AB when we're rotating it around something is pi times the integral from a to b of the outer function minus the inner function, both of them squared. And there's a more complex form of this, but basically this is what we need to know. And since there's no inner function, we know that we can just set our inner function equal to 0. It's really important to remember the pi here because in BC we haven't been doing a lot of things that involve a pi. Just remember that. Just gotta be another thing that you memorize. So you distribute that 2 in there, then you take the integral, very simple stuff when you're dealing with e to the x. Then you evaluate that integral and you're left with pi fourths e to the 4k minus pi fourths. And this looks like it's not completed, but if we remember the question, it says leave it in terms of k, so that's a good thing here that we have a k in our answer. For this problem, it gives us 4 points. One of the points is just remembering the inside of this integral. The second point is the limits of the integral from 0 to k, which we know pretty simply. The third is where a lot of people can get tripped up just finding the right antiderivative. It's really simple, just remembering to divide instead of multiplying. And then the fourth point is for our answer. And this, if you understand what the question's asking, it's really a matter of small mistakes. Which little algebra errors did you miss? Alright, part C. This is my favorite question because it kind of comes out of nowhere. You weren't expecting it. It catches you kind of off guard, but when you read what they're asking carefully, it's pretty clear what you have to do. So it says the volume changes as k changes, of course. If our k is changing, our volume's changing. And it says if dk over dt, so k prime, if k prime is 1/3, determine v prime when k equals 1/2. So our givens for this one are k prime and k, and we need to find v prime. And we don't really have an equation with v prime, we only have an equation with v. So that should evoke the notion of it being a related rates problem. And we need to take the derivative of v in order to find our v prime. So right here is our v. In order to find a v prime, we have to just take its derivative. And we get v prime equals pi k prime e to the 4k. Pi fourths goes away because it's a constant. And then we can just substitute in there into our v prime, and we get a nice looking answer right there. So the 2 points awarded for this question are applying the chain rule and our answer. That's some pretty simple stuff. It's just really recognizing that this is asking for a derivative, and finding the right answer are the only 2 points. So I hope this helped you, Nick. Hopefully you can go ace your test, and hopefully all of you folks can get a 5. Dom Production.